welcome to this video. We are still on determinant by using Gauss reductions. So in this case, we want to use it to solve something completely different. We want to check if these two systems are linearly independent or not. So basically, we know how a system, after using Gauss reduction, is linearly dependent or not, right? When the system has exactly one solution, we say that the system is linearly independent. But if we have many solutions or no solution, then we conclude that the system is linearly dependent, right? All right. Let's start with this first example. So we have this set of 4 vectors. So the matrix from this set is the following: 1, 2, 1, 4, minus 1, 2, 1, 1, 2, 2, 2, minus 5, and the last one is 1, 1, minus 1, and 3. So we want to Gauss reduce this matrix, okay? And as you all know, we can start with these first columns, and we want this entry to be 0, 0, 0, okay? So basically here, we start with this. We write this minus 1, 2, 1, and this is 0, 0, 0, 0. Because of these two, if we say that R2 becomes R2 minus 2R1, then this becomes 0. Here we have 2 minus 2, this is 4. Here is minus 2, and here it should be minus 1. Okay, in the same way, here we have 1 and 1 for the third row. So the third row becomes R3 minus R1. So we fix the first row, right? So here we have 0, 2, 0, and minus 2. And the last one, we have 4. So R4, basically here R4 becomes R4 minus 4 R1. So this is 0, 5, minus 13, and minus 1. All right, this is what we obtain after this the operations on the first column. Now let's target the second column. We want to get rid of these two entries, okay? So let's write it. The first row is the same. The second is the same. Then for the third one, so for the third row, I want these two to be 0. So this becomes R3 minus 2 over 4 R2. So by doing that, we have here 0. We also have 0. This is 1 and minus 3 over 2. For the last one, we have R4. We want to get rid of this 5. So this is R4 minus 5 over 4 R2. So this is 0, 0, minus 21 over 2, 1 over 4. So this is what we obtain. And lastly, so we want to get rid of this minus 21 over 2. We first repeat the matrix. We write the first row is minus 1, 2, 1. Second one, 0, 4 minus 2 minus 1. The third row does not change. And now for the fourth row, we want to get rid of this, as I already said. So this R4 will be, we fix the third row. So this is R4 plus 21 over 2 R3. Okay? So by doing that, we obtain 0, 0, 0, and minus 31 over 2. Okay? So from here, we know that the system has exactly one solution. And as you all know, as I also mentioned from the beginning, when the system has exactly one solution, it means the set is linearly independent. So this set, by conclusion, this set is linearly independent. So this stage is enough to make a conclusion, because everyone can see from here that this set has exactly one solution. Okay? Conclusion, the set is linearly independent. Now let's look at this second set. So the matrix forms of this is 1, 2, 1, 4, minus 1, 2, 1, 1, 8, minus 4, minus 2, 7, 1, 1, minus 1, 3. Now we want to do the same. We want to repeat the same process here, because we still have to say whether this set is linearly dependent or not. So basically, I want to get rid of, I fix my first column, and I want to get rid of these entries, these 3 entries, so that you have an upper triangular matrix, as we did here. First thing here is to fix the first row. This is 1, minus 1, 8, 1. So this other side we have 0, 0, 0, 0. So for this, I want this to be 0. And for that to be 0, I will say R2 have to be R2 minus 2R1, right? So if we do so, we have here 0, 4, minus 20, and minus 1. Okay, for this one, we have to get rid of this 1. So this means R3 will be R3 minus R1. If we do that, this minus this is 0, here is 2, this minus this is minus 10, this minus this is minus 2. And for the last one, I want this to be 0, so this R4 have to be R4 minus 4 R1, because we have 4 here. So doing so, we have 0, 5 minus 25 minus 1. All right. The first column is sorted. We want to move to the second column now. We want these entries, these 2 non-diagonal elements, to be 0. So I start with this one, and I have to fix the second row. So we copy the first row and the second row. And for the third row, since we want to get rid of these 2, so I will say R3 will be R3, since we have 2 here, so this is minus 2 over 4 R2, okay? Doing so, we have 0, 0. This will also be 0, and the last one is 0. Now for the last row, R4 will be R4 minus, we have 5 here, so this is 5 over 4 R2. We have 0, 0, 0, 1 over 4. So something has happened here. As you can see, this third row is 0, right? Can we make a conclusion from here? Yes, we can make a conclusion. What is the conclusion? Is that this system is not linearly independent because it has many solutions, right? This system has infinitely many solutions. By conclusion, we will say that the system is linearly dependent. Because it has infinitely many solutions. This is the reason why this system is linearly dependent, because it has infinitely many solutions. And remember here we said the system was linearly independent because it has exactly one solution. So I can write it here, because the set, right? Because the set has exactly one solution. So in this case, but here is infinitely many solutions. So you can see that using the determinant, it is easy to show that a set is linearly dependent or not. This was a very simple one. So thank you. I look forward to seeing you in the next video.